Okay, so we're going to get started, and I thought, because we ended the lecture last one Monday kind of quickly, and so you're going to be confused in this class. There's no doubt about it. So frustration is normal. I can't. It's sort of like imagine you had one semester of Chinese and you moved to China. Well, think how frustrating that's going to be, right? You're going to try to communicate and you can't say what you're trying to say. You're going to choose the wrong word and you're going to still feel silly, But that's what you're doing, okay? So you can't make it any easier. There's going to be that. And the point of these labs is to kind of give you the experience, so you kind of understand how this thing works. And we're going to work out the kinks in your mental model of what's happening, so that when you do the homework assignments, it actually works a lot easier. Okay. So that's it. I can't make it, unfortunately. I've taught this class 13 years. There's no way to make it so that it makes perfect sense.
Does it ever make perfect sense, Tom?
It makes perfect sense to me.
Okay.
Yeah.
How long did it take, though?
It didn't take long.
Okay.
Yeah. It didn't take long.
Years?
Yeah. No, I mean, because I've been programming a long time, when I finally had to do the object-oriented stuff, it wasn't that hard. But you're trying to go really fast to a high level. And, if you could work a while with just what you learned from 10A and then take 10B, that would be okay. I mean, it would be easier for you, but these things take time. It's just you got to get you're basically trying to form a mental image of what's happening. It takes a while to kind of get the right thing, and it's okay if you take a wrong detour somewhere. I'm trying to kind of steer you back, and so and unfortunately Steve kind of led a couple of you guys down a wrong path as well. So
are we still going to get the array drills? I know you had mentioned something about
yeah.
over the holiday
Yeah.
that there was going to be like an array drill.
Yeah. Yeah. What would you like to see on it?
Well, I'm pretty adjustable. I mean, pretty much, I just have the flashbacks from when his nephew. I remember his last name, but I don't remember his first name.
Right.
Dave.
Yeah.
Dave had an array drills exercise that was really great, but I don't know how you would have something that would bring us more into what we're doing here.
Yeah, I will.
I don't know.
Yeah.
Pretty much anything you can throw on there. I mean, I probably.
Yeah. It'll probably be, and you don't have to do all of it, but it'll be just a bunch of stuff you can look at, and I'll step you through some activities and give you some pointers and stuff, and throw some pictures up there. Daniel's not here right now, but when he shows up, ask him. Yeah. If I forget, just raise your hand or something too, because I know there's a lot of people are interested. People are interested in that programming competition, right? Yeah, and you can tell him when he shows up, or if he shows up. Hopefully he shows up. So let's start briefly. We're going to cover a new data structure today, and we're going through this kind of fast, okay? That's the way it is. But it's a lot better than it was last year, I'll tell you that. Because it's a lot less volume of information. I'm lecturing a lot less. So I'm giving you more time to do stuff in the class. So we're going to learn stacks today, but I want to just touch on Lab 2, so you might pull that up real fast. Lab 2A. And Lab 2A was asking us, to add a new person, Joe Frank and all this stuff, and then it asks you to make the equals method. Did we do that together, or did?
We did it in class.
So you got the equals method going for the person class, right? Did we do that?
Mm-hmm.
Yes.
Yeah, good. So we're able to compare two person objects and see if they actually are the same person. They have the same name, basically, is how you know that, right? Now, the beauty of it, and this is what the bag's responsibility is. It has this contains method that can tell you if the bag actually has what you're looking for inside it. And let's just add a couple more people if you haven't done that already. Supposed to add Lara whatever. Lara Allende and Presley Underwood to the bag. Very unlikely names. And print the bag context, you can do that. Well, actually, that's being done right there. Now, an equals method, so we did that, right? So we did B. So C, it says, prove that your equals method works by determining if Joe Frank is in the club. So we're going to say system out dot print line. It's all going to be one line. This is the beauty. The bag does all this stuff. I know, Amit, you tried to do a loop to pull out everything in the bag and see if that was the same. And yeah, that's one way to do it. But you're defeating the purpose because the bag has these great methods to make your life easier. That's why we're using these data structures. We're using these collection classes to make our life easier when we're working with stuff. So now that we have an equals method for the person class, which we'd kind of have to write anyway, you know, this is nothing unusual, we can say does or is Joe Frank in the club? And the answer to that question is just going to be one expression. Okay? Help me out here. What's it going to say? Christian, question?
You're using the contains method. So the contains method by default calls the equals to.
Well, think about it. But I'll explain it more once we actually express it. Okay. So what's going to happen? Yeah. Go ahead.
So by using the contains method, where are we using the equals?
I'll explain that, but let's keep on going. Okay. So it's not my bag though. What's the name of the bag? It's the CS Club. CS Club dot contains. Now, the contains method needs a reference to the object that you're looking for to see if what you're looking for is in there, right? So what we have to do is we got to make a new person temporarily so that we can feed that to the contains method so it can tell us if there is an object inside the bag that equals the object that we're looking for. Notice I said equals, Christian? Okay. So if you've got 5 items in the bag, and the search entry, the one you're looking for, the thing you pass to the contains method is called an entry, say, or whatever. So you have to look at the first item in the bag and see if that equals the one you're looking for. Okay? If it doesn't, you look at the second one. Does it equal the one you're looking for? This is all happening inside the bag class. You're going to write this in a few weeks. Yeah.
Well, right now there is a pre-written method, so essentially it would be automatically sorting through every unit and doing an equals to.
Until it finds it or it gets to the end of the list of items it has. And then it just returns false if it hasn't found it by then.
So the equals method is already in the bags class.
No. The contains method is in the bags class. But you're storing person objects in the bag class. So when you're trying to, this is the thing, that the bag class is generic, so it works with anything. But it's going to have to use equals to compare the object that you're looking for with the object in the bag. That's the equals method for the class of objects that you're storing in the bag. So if you've got a bag of students, you're going to have an equals method for the student class to be able to check if a bag contains a certain student. If you've got a bag of employees, in order to know if the bag contains a certain employee, the employee class is going to need to have an equals method defined for it so that contains can work properly. Because contains, imagine internally, is comparing all the objects in the bag to see if they match the target one that you're looking for. And that's all being done with the equals method. Yeah.
So, in what situation would you use a bag instead of using an array or an array list or some other kind of data structure? This seems really random. I like to know where my data is.
Because sometimes you don't care where the data is.
And so does this use less memory, or what are they?
It's just simpler. And the idea is we should use the simplest thing that we need to do the job. So for instance, in the homework assignment, you're going to make a program that that imagines cutting off the heads of a hydra, right? A hydra is something that has a lot of heads, and so you're going to model the hydra as a bag of integers. And each integer is the length of a head, or the size of a head of a hydra. And you're going to remove a head from the bag, the hydra, chop it off, and then you have to put two smaller heads back in the bag, because that's what happens when you chop off the head of a hydra. You don't care what order you're chopping heads off of the hydra. Well, maybe you do, but in this case you don't. It's just chopping heads. Okay, it doesn't matter if it's the first head or the last head. If there's a head in the bag, you got to keep chopping it off.
We should put the victory heads in a bag too, because if you're going to cut the most heads off the hydra, you might as well keep a bag.
Well, there's another bag to keep track of how many chops you made, and it's just every time you cut a head off, you put the word chop in the bag, and that's sort of counting how many chops it took to cut the heads off. Okay, so that's an example. Of course, that's part of this class. We're going to be looking at all these data structures, then we're going to figure out, oh, which one should I use for this particular problem? But that comes later, because you got to look at a few more.
On an eclipse-related question, where do we put the workspace to have it available on any of the computers that are logged into our
On your U drive.
on the U drive?
Yeah.
Okay.
Mm-hmm. Okay. So that is the answer to that. Oops, you might need another parentheses. Okay. And I hope that clarifies things. Cannot find symbol variable CS club. Lowercase club.
Also, a new person object, since strings are case sensitive, that new person object would be different.
Oh, this is supposed to say Joe Frank. Sorry?
So if you had Joe Frank with capital J and F, and Joe Frank with lowercase j and lowercase f, that's a different object.
Yeah. But you could define the equals method for the person class to use equals ignore case when it compares names, and then it wouldn't matter. And that gives you some control about the definition of what equality means. And that makes it nice, too, because you have that ability. Your object that you're putting in the bag, if you want the equals method to work a certain way, you can define it that way. Yeah.
Or you can add Joe Frank to a variable person, but before, when you created it the first time, and you're going to have to create another person.
Say that again? Oh, if you made a variable to refer to Joe Frank?
Yeah. It's like person A equals new person Joe Frank.
Mm-hmm. And then you can see if it contains person A. Yeah, that would work too.
Yeah, and you save memory because you don't declare another object of person.
Sure. Yep. Good thinking.
So this object that we created of the type person is temporary in order to check.
Yeah, it's creating a temporary object just to check to see if the name is the same as the one that's in the bag.
And that's where it's using equals method.
Yep.
So
Yep.
if you don't have the equals method in the person class, it would give us an error.
No, you know what happens if you don't write the equals method in the person class? Because the person, remember, every class inherits from object. The class object has an equals method. But the equals method for class object just compares the reference index, the address in the reference variables. And if those are the same, then it would work in your case probably when you had a variable A, because that would be the same object. But in the general case, when you have two different objects, it wouldn't work, even if they have the same data.
So in this case, if we don't have equals method, it would just return
False. Yep. Yeah, good question.
The original contains method, it's not equals in each position. It's if it contains that thing in the object.
Mm-hmm.
It's like array list dot contain. It's an array list of strings. Contains hello. It shows you all the positions that are the string hello. But maybe it's XXX, E said hello, XX, and it's true because it's contained. It's not equal.
Mm-hmm. Yakov, you had a question?
Yeah.
For the person class?
Yeah.
And it's very similar to the one on the slide. You check to see if other is an instance of person. We're passing as object other. And then you say, then you cast other as a person and store it as that. So that is a reference to the other object through a person filter. So you can activate the person methods.
Yeah.
And now, when you write the equals method for the student class, remember, part of the student is stored in the person class that it's inheriting from. In other words, the name is. But the person class has a getName method. So you could do the same casting, Boolean, other instance of student that equals student other, and then you can say this dot getName to get the name of the student equals that dot getName, and this dot student ID equals that dot student ID. If both of those conditions are true, then you have the same student.
You're pretty much just checking one thing because it's gone one layer down.
Well, now, to be the same student, you should have the same name and the same ID number, unless you just want to compare ID numbers.
But that's not really the same.
Technically, each student should have a unique ID number.
But if they go to a different school?
Well, in a student database at school, you wouldn't have different schools. But yeah, but again, it depends on how you define it.
What's this do?
What does the word this do?
Yeah.
So the word this is a keyword that it's like an instance field that every object has that you create. And what it contains is the memory address of the object that it's inside. It's referring to itself. That's a really good question, and I think that needs a sketch. So let's sketch something here. And so suppose we have, a person, Joe Frank, right? So we'll make a, we'll just call person P equals a new person, and Joe Frank is the person, right? Okay. Now, P basically holds the address of where that object is stored in memory, right? And Joe Frank is actually, it's actually the name field of a person. And I'm just throwing it inside that box, although technically, of course, the Joe Frank would be a string that's stored outside the object. Again, we sort of have different levels of detail in our models. But there's another variable in that object that is implicit. It's automatically there. We just never have to declare it. It's called this. And this has the same value that this variable P has. And so you can even imagine that this is actually a reference to the object itself. Okay. So if you're saying like, if P dot equals Q, where both P and Q are separate objects, okay, and Q has its own this field, right, and Q has its own name, right. Well, if P dot equals Q, what happens is we jump into the equals method for which object? P or Q?
P.
Yeah, who owns the equals method in this relationship? When we say if P dot equals Q, who owns the equals method? P, okay. So in this, where was I anyway? I was here, wasn't I? In the person class. When I'm looking at the definition for the equals method, you should understand that this, in the case of P dot equals Q, this is a reference to P. So it's saying if P's name equals that, and of course Q is actually passed to this parameter other, right? So other is another name for Q. This is another name for P. And then when we cast other into this person that, that also is another name for Q. Is your head spinning?
It was because we use contains and contains uses that, and I don't get it.
Now you get it. Yep.
It was
Mhm.
weird because this was not, didn't look like an array, but it wasn't, because it's using the contains.
Yeah, contains is using equals inside, but it's happening internal. This is why you have to do this.
This just contains.
Yeah, and that's what happens for all of you. All of a sudden, it's going to click, and you're oh, now your mental map is clear, and then it makes sense. You can code really. Amit, and then Willie.
Like with the clone method, we have to write another clone method which overrides the actual clone method of the object.
You could, but it's not so important in this class. It's something we may consider at a certain point. When you actually want to make a duplicate copy of something, the clone method is pretty important. But our book it actually doesn't cover it that much, and it actually puts it. There's actually an appendix online that it actually talks about the clone method. But if you're interested, I can talk to you about it sometime. Just there's just so much stuff. We might just not cover that. Willie?
Yeah, so I was wondering, so since other is an object of the class object, that's why I have to cast it into a person and then store it back into that which is an object of person, right?
Yep, that's because if we don't do that, then we can't refer to that dot name.
Okay, and then the line return this dot name is the one that actually does a comparison between the two.
Yeah, this is saying really essentially this is saying if the name of P, because this is the same thing as P, it's referring to the same thing as P, and that is referring to the same thing as Q. So in other words, if P's name equals Q's name, then we're going to return true. That's what the equals method does. Yeah. You're going to write that code. Yeah. In a few weeks, you're going to write that. Yeah. And in the review content I'm going to give you this week, I'm going to give you some array review. And then I'm going to give you, because an array is going to be one way that you can make a bag. A bag can keep track of all the items inside the bag with an array. Another way to keep track of a bag is a set of a chain of linked nodes, where each node has a reference to the next object in the bag. And I'm going to show you both of those in the review thing. That's going to be a preview for what's going to come up when we actually get to make our own bag class. And so you're going to write a contains method that's going to actually use the array. Well, you're going to make a whole bag class that uses an array and another bag class that uses a linked chain of nodes. And the method to do contains is going to be a little bit different, but it's the same idea. Yeah, that's all coming. By this time last year, everybody was just like, oh my god. So that's because they actually had to build the bag class before they actually used it. And they they had no idea what they were actually doing. It was just really messy. Yeah. So now you're using it. I think you're getting a sense of what it is. You're going to have some, oh, that's what happens. A few of those, and then you'll be on your way. Today's class is actually easier than the bag class, by the way. It's actually simpler. So any other questions? If not, I'll start on the lecture for stacks. And it's a short lecture, luckily. Let's see, 2B. And so a stack it's a fundamental. The bag class is really not used a whole lot in coding. It's pretty simple. You just stick something and you take it out. There's not too many problems that a bag is going to be too helpful with. But a stack is actually used all over the place in computer science. It's a very simple data structure, but it has so many uses. It's a very powerful data structure for what it actually does. For instance, you can use stacks to evaluate algebraic expressions, arithmetic expressions. And in an easier way than infix expressions, the ones with anyway, we'll talk about that. And we'll see how we can use a stack to do some arithmetic, and you're going to get to play around with that in the lab, and then on the assessment, you can actually work on that as well. So did other people have problems loading the assessment too? Someone said they had a problem activating assessment too. Just kind of curious.
It just took a long time to go in the right.
Yeah,
Oh, okay. Well, you know what I did? Because I thought it might help, I actually rolled back the Java that I used to make it. So I think it's your local machine, if your local machine has the wrong Java, it may take longer. But I back compiled it so that it would be an earlier version of Java because I thought that might make it more compatible with people that didn't update their Java yet. I don't know if that helps or not, but I could always recompile it with the latest version of Java, see if that makes a difference. But
It's not taking points out for the space.
yes, it now has flexible spacing. So it's not going to be too anal about the spacing. So if there's a space in the answer, it's an optional space, unless I put an underscore in the answer, which then it's required. Hi, Daniel. Everybody's wondering when the next competition is going to be.
Well, I still don't know. The guy has told me.
Okay.
I'll let you guys know.
Okay. All right. Sure. Yeah, I had fun doing that this weekend. I redid the algorithm for the check thing, so it was fun. It was actually not easy. So what is a stack? A stack is basically the idea of a stack. When you visualize a stack, is you can think of a pile of books where you stack them up, a pile of plates like at a cafeteria, a pile of bowls, pile of gifts, and there's only a limited number of methods in a stack. The thing about a stack is, in terms of a stack, whereas a bag, the order didn't really matter for a bag. With a stack, the stack keeps track of the order in the sense of it keeps track of what's the last thing you put on the stack. Because if you want to take something off the stack, that's the thing you're going to get, right? If you take a book off of a pile of books, you get the top book, right? If you take a plate off of a pile of plates, you get the top plate. And that's the idea of a stack. If you want to put something on the stack, that's called push. The method is called push. It's a standard method for stacks. If you want to take something off a stack, it's called pop. Okay, you pop it off the stack, and it takes it off. That's just like remove for the bag class. Yeah.
So since you have no option for which one to take off, these methods don't take any fields, right? They just do it and they just.
Yeah, they're just no arguments. It's just, well, the push needs the thing that you want to put on the stack.
Oh, yeah.
But the location doesn't matter. See, we're building up the complexity. Later on, we're going to look at a list where you can insert something somewhere in the middle, if you want to. But we're building it up slowly, right? The complexity. So the bag was the simplest. Here are the method summaries for a stack. You can clear a stack, which removes all the items. You can check if the stack is empty. You can peek at the stack. Sometimes the word top is used. I have to verify. I hope that's the correct name. Peek looks at the top of the stack and just returns a value, but it leaves it on. It just tells you what's there, but it doesn't take it off. Okay. Pop actually removes the stack. Notice they both return these generic type T's. So this is the thing that you're making a stack of. A stack of strings would return a string, right? A stack of students is going to return a student when you pop it. And then there's that method push, which takes an item and just pushes it onto the top of the stack. What's missing? There's one noticeable method that's missing from this stack. Is full. We have an is empty method, but not an is full. Why don't we have an is full? Well, it could, depending on how you code the stack class. Now, this stack class and the ones that I think that we use in this are actually expandable. So there's an array, one version of the stack, there's an array inside it. And if the array gets full, it just makes a bigger array. All behind the scenes, so you don't have to worry about it. It just resizes itself transparently to you, so you can keep adding stuff to it. So it never gets full. Well, it could get full eventually if you let it run long enough in an infinite loop. Okay, but for most applications, it's just never going to get full. Yeah. Okay. So, but notice there's this keyword. This is not a class. Okay. There's something else different on this slide. It's an interface. Okay. It's not a class. Have you had interfaces before? I know they came up in 10A. I'm not really sure what they are, but you've seen them. So whereas the word extends indicates what? Inheritance. The word implements indicates interface. Okay. Somewhat similar, but not at all. And again, I'm just going to give you a little bit today, and then we're going to give you little dribs and drabs, and eventually you'll get the big picture of how all this stuff is organized for laying out complex software systems. But I don't want to talk about that today. It's too much. But the interface, just for now, what the interface is a contract, which it doesn't. An interface is not a class, so there's actually you can't make a stack interface object. But you can declare a variable of type stack interface and assign it an instance of a class that implements the stack interface. And what that does is it gives programmers flexibility, because the interface is like a contract, but it doesn't specify how you actually make the stack. And you could decide to make the stack a number of different ways, as long as your stack has these methods and it follows the instructions of these methods. Then from our level, it's a stack. It doesn't matter how it works, except that certain implementations, depending on our problem, may be more efficient than other implementations. Okay? And that's why we have interfaces, to allow us some flexibility of choosing how we actually make the thing. In order to define an interface, it looks very much like a class, except instead of the word class, it just says public interface, stack interface. And instead of actually defining the methods, it just has the method signatures. You see that? It just says, public void push, blah, 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 semicolon, right? That's it. That's just the first line of a method. It doesn't have any bodies. None of the methods are defined in an interface. The only thing that's defined is the name of the method, the return type, and the arguments that method has. And that's the contract that has to be met when you make a class that implements the interface. And we're going to run into that when we actually build a stack class. But for now, it's not that hard to use. Like a class, an interface is like a class, but none of the methods are defined. Only signatures showing what they take and return. And it's like a contract. If a class satisfies the methods in the stack interface, then it's a stack. And it can be used interchangeably with any other class that satisfies the methods in the stack interface. Which means, like, I could, if I don't like the way my stack is running, maybe an array. See, because a stack that has an array inside it and all of a sudden has to resize it when it gets to a certain size, that's going to have a noticeable delay for certain times when you push something onto the stack. Occasionally, when it has to resize everything, it's kind of like, oh, wait a second, I got to make a bigger array here, and you copy everything over, and you're like, okay, now I'll take it. Okay. And that could be fatal for certain applications that you're writing. Whereas a stack that just has a set of chain of linked nodes is just going to always be the same execution speed no matter what. It just makes a new node and adds it to the end. Makes a new node and adds it to the end. So the speed is uniform. Okay. So those kind of things then allow you to, if you have stacks that are implemented different ways and one approach isn't working that well, you can easily switch it with another approach that doesn't require you changing anything else in your software except the kind of stack that you're using. Okay, so for instance, this is going to be what's the inside of a stack that uses an array, and you can see each cell of the array is pointing to the different objects, and we might have the top entry of the stack as we go into the array. So this is like array cell 2, that's the top. And this is going to be, this was the top, and then we return something, and we lower the top end. So we keep a variable here that maybe indicates where that is. None of this you have to worry about. This is actually a preview of what's going to happen when you actually make a stack. But this is what a stack of a chain of linked nodes looks like, where each node has a reference to a object in the stack, and then a reference to the next node in the chain. And this is what we're going to play around with a little bit in the preview thing I'm going to give you this weekend. So you just kind of play around with building these things. You can kind of get a sense of how they actually work, so they're not too crazy when you see them. Again.
It's like the pointers and linked lists.
Yeah, it's a linked list, like you did in C++.
Okay.
But it's exactly the same, but the syntax is just a little bit different. Because Java doesn't have any explicit pointer variables, but every object reference variable, every variable you create that refers to an object is really a pointer in Java. So you don't have that star symbol in Java that you do in C++, because every object reference variable is a pointer. So you're going to see how that works in the little demo I'm going to give you. It'll be pretty simple, just kind of a follow through, and hopefully that will give you some understanding about that. So that allows us some flexibility to choose between either an array stack or a linked stack. And then here's how it actually works. So using class stack, we say stack interface. So the idea is you make the variable string stack of type stack interface of strings. That's the interface. And then it equals a new, and then whatever class is that implements the stack. It could be our stack, it could be array stack, it could be a linked stack. Whatever it is that satisfies the contract, you can use that. And then everything else is the same all the way down. You can push Jim onto the stack, Jess, Jill, Jane. Jill, you're pushing all these things onto the stack. Who's on top of the stack at the end of those statements? Joe, the last one is on top of the stack. Jane?
Have you ever seen anybody use two stacks and just remove one and put it into a new stack?
Sure.
Pop and push.
Yeah.
Push, pop and push.
Yeah, you can move from one stack to another. Yep. Oh yeah. Really? There's actually a, it was a sort of a homework problem I had last year, but it was kind of fun. You could actually make a sort routine that uses stacks. You move it from one stack to another. It's really
just like peek. And
yeah.
Then if not, then pop. And
I'll put that out there sometime as an extra credit thing for people that want to try it. A sort method that uses stacks. It'd be really fun. Yeah. No, good question. So if you say if you just want to know who's on top of the stack, you say string stack.peek, and it's storing a reference to that in this variable top. So now top is referring to the top thing. Joe is still on the stack. We just looked at it to see who was there, and we got a reference for it. So it says top, and it's going to say Joe is at the top of the stack. Okay. If I say top equals string stack.pop, that's going to refer to Joe again, but now Joe has been removed from the stack. Joe is no longer on the stack. Okay. If I say top equals string stack peek, it's going to return Jane. That was the second from the top. And if I pop it, then Jane is removed from the stack. Okay, so that's basically the mechanics of working with a stack. Pretty simple compared to the bag. It's simpler because there's less stuff you can do. So this is how it actually works when these statements are run. First we push Jim, then we push Jess, then we push Jill, then Jane, then Joe, and then we're popping them off. We're popping off Joe, and then we're popping off Jane. Okay, that's how that works. So as an example, after the following statements execute, what string is at the top of the stack and what string is at the bottom? Can you all see that? We're pushing Jim, Jess, popping, pushing Jill, Jane, popping. What string is at the top of the stack? Jill. What's at the bottom? Jim. Good. The first thing you push is at the bottom. Good. That's it. Write a loop that pops the strings from string stack and pushes them on to name stack. There's your answer right there. Okay. So here's the answer to that. So in other words, while not string stack is empty, name stack.push string stack.pop. Okay, that's how you do it. Your questions. Yeah. So we're emptying all. We're removing as long as string stack is not empty. We're going to remove. We're going to pop something from string stack, and push it onto name stack. Okay. Now when you do that, string stack is empty. And name stack contains all the strings that were in string stack, but they're in the reverse order, right? Because when you do that, right, if you took a stack of plates and you moved one plate onto another stack, just took one plate, moved it, at the end, all the plates are going to be in the reverse order on the second stack, right? You just flip them around because the top plate is now on the bottom. Yeah.
Yeah, so is there a problem with memory leakage in Java like there was in C++, or they have function for that?
So much nicer. Yeah. Yeah. Yeah, you don't have to worry about that at all. In C++, you have to write garbage collectors yourself, with those destructor functions and all, because if you don't, you have memory leaks. You can't do that in Java. It just there's a garbage collector. When an object, what the garbage collector does, it's actually another process that runs around looking through memory, and when it finds memory that has nothing referring to it, it reclaims it.
Or in C++, you have to like go and
in C++, that's called a memory leak. But in Java, it just wipes it out. Yeah, yeah. That's another reason why Java is really nice. Okay, applications of stacks that we can actually contemplate pretty easily are arithmetic statements. What happens when the compiler does, when your program is trying to evaluate arithmetic, the compiler is translating an expression like a times b plus c into machine language. And what's happening in machine language is it has to load the variable a, and then it multiplies that by b, and then it adds c, and then the result is stored in x. And this is actually assembly language code. If you take CSIS10, you learn how to write instructions in assembly. And it's really tedious.
You have no idea how horrible that is.
Yeah.
I had to write a calculator.
Yeah.
Yeah.
Yeah, it's very tedious.
I would rather
And
like
this expression is written in infix, and there's a certain cost to doing that because the actual natural way to process math expressions on a computer is with a stack or postfix notation. Most compilers convert the expression from infix to postfix so that it's easier to turn that into assembly language. And what postfix means, does anyone have like those HP calculators that are reverse Polish notation? They used to be pretty popular. Yeah, reverse Polish notation.
yeah.
They're faster because you don't have to use parentheses. So you can actually get to the answer really fast, but you have to think in terms of stack to be able to do it right, because that's how you process postfix expressions. So a times, and we're going to learn this. This seems kind of, we're learning arithmetic today, but it's a kind of arithmetic that uses a stack. So by learning this arithmetic approach, you're going to get an understanding of how stacks actually work and how they can be used in many cases. Okay, that's why we're doing this. And you're going to have drill exercises in arithmetic using postfix notation. So you have to understand how that works so that you understand how stacks work. Okay, so a times b plus c is infix. In postfix, it means a b star c plus. In other words, the operator comes after the operands. A and b are the operands, and star is the operator. So we move the star over there. We say a b star, and then c plus. Okay. And so that's a very convenient order for processing an expression with a stack. And so for instance, if you want to say a plus b, that's going to be ab plus. Another way of expressing it would be prefix, but we're not going to use prefix. You can just ignore that. Postfix is what we're looking at. A star b plus c would be ab star c plus. A star b plus c is going to be a, but you got to get this result on the stack, so you got to say bc plus, see no parentheses needed, and then star. Does that make sense?
Yeah.
Kind of? Yep.
You get crazy, of course.
What's that? Are you worried about getting crazy? A minus B minus C minus D. Okay. So A, B, C, yeah, so this has to be done first, and it is, because the stack is going to process the top of the stack first and work its way down with all these operators. So CD minus is done first, and then D minus that is done next, and then A minus all that is done last. But then A minus B minus C minus D would be AB minus C minus D minus. Yeah.
Why on earth would anybody try to do this on a calculator? Just so they don't have to put in a couple of parentheses.
It's faster. And
what on earth are you doing?
if you're doing a lot of computation,
Yeah.
yeah, and people that are doing this, some like accountants and stuff, it would actually be faster. You would save a lot of time, right? Think of all the parentheses you'd have to type in.
Think about all the parentheses if you're doing math all day.
Yeah.
And then if you spend like a week learning this, just dedicated.
It's very intuitive once you get the hang of it. So here's how you evaluate. Here's how you evaluate these things. And there's a couple different ways. You might follow the slides if you need to do this, but I find it's actually not too hard. You scan the expression from left to right to find an operator. Okay. locate the last two preceding operands and combine them using this operator. So we start here, right? And we have an operator, right? So as soon as we hit an operator, we actually look at the two operands to the left, and we apply the operator to those two guys, right? That gives us 7, right? 3, 4 plus is 7. Then we continue with our expression, okay, 5, 6, minus, and when we hit that minus, what happens? 5 minus 6 becomes -1, okay? And then we've got another minus, okay? That means 7 minus -1, so that's going to be 8. And then we got another, we got a star, okay? So that's 2/8 star, which is 16, okay? So you have to do this. You have to do this on the test. And you know, compared to the coding problems, this is easy. You're going to look forward to these. These are easy answers, okay? Because you don't have to write code. These are easy, yes. Okay. Well, how would you do that in a computer program? Because that's what you're going to work on in the lab today. How are you going to do this in a computer program? So what happens is you initialize a stack, and here's what you do. You get the next token from the expression that's read. And there's a nice way of doing it. There's a string tokenizer class. We saw that in 10A in my class anyway. String tokenizer class, it gives you the tokens. Very handy. And you do that until you get to the end of the expression. You get the next token. Okay, it's either going to be an operator or a digit. And our expressions are just going to involve single-digit numbers, just for simplicity of reading these things. Okay. So if it's an operand, that means if it's a digit, you push it onto the stack. Okay. If it's an operator, you're going to have to pop the next two values off the stack. The top two values off the stack. The last two values that were pushed onto the stack, the last two numbers that were pushed onto the stack are popped off the stack. Then you apply the operator to those values, and you push the result back onto the stack. And then you keep processing the rest of the expression. And as this expression is being evaluated, you can imagine the stack is growing and shrinking until it gets back to, when you're all done with operators, you're just going to have one value on the stack. You just pop that value off, and that's the result of the expression. Okay, that's how stacks work, and they're very fun. They're very cool that way. If there's ever a situation where you reached an operator, but there was only one value on the stack, then that was an illegal expression. It's possible to write illegal postfix expressions, and in that case, your program should just abort or throw an exception. Yeah.
What happens if you're adding like 15 plus 5, but you put it to 2
You're not going to in this program.
Oh, okay.
You're only going to be able to add, 1 through 9, or 0 through 9. Yeah, in a more complicated program, you can imagine other ways of reading in multiple digit numbers, but not in this program. It's just going to be really simple. And then here's an example of one being evaluated. And this shows you the expression that we're reading at token after token. It's kind of small. I don't know if you can see that, but the arrow is indicating the token that we're currently processing. And we're pushing that onto the stack. Then we get to the 4, so we push the 4 onto the stack. Then we get to the star. We pop the 2 items, the 4 and the 2. That becomes an 8. And we push the 8 onto the stack. Right now the stack has been collapsed. Then we do we find the 9, so the 9 gets pushed. The 5 gets pushed, and then we hit the plus. The 5 and 9 get popped and replaced with a 14. Okay. We hit the minus. The 14 and the 8 get popped and turns into a -6. That's the answer of that expression. Now, what's amazing about stacks, and depending on where you end up going in computer science, this is a really fundamental step in compiling code and language processing. There's something called, it's like a name escapes me. But this thing this process that works with arithmetic also works with languages. So you can use a stack to process languages, and like if you get like if you have a noun, you sort of like keep pushing phrases down until you get to a verb, and then you pop that whole thing off, and now you sort of have a complete sentence. And so our human brain is actually using stacks all the time. For instance, there's certain languages like like when you have a clause inserted into a sentence, like the student who came from Mars, 10 years ago, walked home, right? Well, we just sort of jumped to something else, like who came from Mars 10 years ago. And what happened to the student, well, that was sort of pushed onto our stack because we were expecting to come back to that later, right? I had a sort of a phrase there that just digressed into some completely different area. And then I'm waiting for that thing to finish so I can come back and process the rest of the sentence in my head, right? This is a natural feature of all languages. Yeah.
It's kind of like recursion, right?
Yeah, it's kind of like recursion too. And stacks are used to process recursive methods. And another example is, I'm getting ahead of myself. Should we try some of these? You want to try one of those? We'll just do one. If A is 2, B is 3, C is 4, D is 5, and E is 6. In fact, I'll write it up here. You guys can tell me what to write here. So I'm going to say AE plus. Okay, so here's my stack. My stack is 2, and then it's 6. And then I hit the plus. What happens? I reduce that to an 8, right? And then I got B, which is 3. Okay. D, which is 5. And then minus. What happens then?
-2.
Yeah, that becomes -2. Okay. And then divide means 8 divided by -2, which is -4. Okay. And the other ones, there's some drill exercises for you to play around with in the assessment this week. As you get into that, you'll learn how to do that. So also, there's a stack algorithm to convert an expression from infix to RPN. If you're curious, you can read about it. I'm not going to explain it. You'll start to get sleepy if I talk through all these things. But it's there if you want to read about it. And our book has a lot more examples like that as well. This is the algorithm for that. One thing I will say, though, that another area that stacks are used all the time is in the program runtime stack. Okay? And when you have a method, a program that has methods, right, and you jump from one method to another, just like I had a statement, I jumped from the main clause to a subordinate clause. The main method has to be stuck on the stack. So for instance, here's main, and we're executing these lines, and we're actually executing the line y equals method A of x. Well, we're going to jump into method A. But the computer has to remember what we were doing in main when we jumped into method A, so that when we come back to it, it can pick up where it left off. So it makes something called an activation frame, which just indicates we were running method main. The program counter, actually that's when we start running main, it makes an activation frame. Program counter is at line 1, and the argument was nothing, or whatever, and that's the argument right there. And as we run this thing, when we get to line 50, that's PC, that's like our line number, the program counter. When we get to line 50, we're jumping to method A. So we're going to actually store x equals 5 and y initially is 0 because method A hasn't come back with a value yet. So we jump into method A and we make an activation frame for method A. Program counter is at 100, A is 5. That's the parameter that it got. And it processes method A until it hits this call to method B. Okay. Every time you make a call to a method, you get another activation frame on your stack, which is keeping track of the last thing that you were doing. And then when the methods start to return, method B returns a value to method A, or it just returns to method A. It pops it off the stack, and pops it off the stack and returns those items back to where it started from. Okay, that's it. End of lecture. So I squeezed in just the essentials. Okay. So would you like a break now, or should we dive into the lab?
Yeah.
Break? Okay. 10-minute break. We'll start at 22.
This is used with threads.
Sorry?
This is used with threads.
It's used with threads too. Yeah.
So two threads don't go at the same time. So the data, you don't lose data. Because if you
Yeah.
get at the same time at the memory, they can break the code.
Yeah, you have to lock out the different memory blocks.
When you finish, you finish. When you finish, you finish.
Yeah.
When are we supposed to finish line 2A?
Like by next Monday.
Next Monday?
Oh, Monday's a holiday though, so
So Wednesday.
yeah.
And we're starting now 2B?
Yeah, we'll start 2B. And yeah, so I'm just going to keep throwing this stuff out at you. You just got to get as much done as you can.
I just want you to show what I did today on Android application.
You wrote that?
Yeah.
Very cool.
With
Is that using Google Maps or something? What is that?
yeah. Oh my God.
Oh, very nice.
This it's kind of just the home, but I have to prove more.
This is home?
Yeah. That's Google. It's
Madrid.
like Google Maps.
Hmm?
And if you press on, you will get this, and you don't see it, but if you press, it says to the computer, you press on latitude X and all that.
Cool.
And all that. Yeah.
Very nice.
I hope you like.
Yes, very nice. We need to have an Android class,
It's
That would be good.
but none of us have time.
This is like my.
None of us have time to teach one. The problem is with education funding and all, we're losing faculty and not replacing them. So faculty are just getting more and more stuff to do. We never have time to do that cool stuff. Yeah.
I wonder could they offer it as like a directed study?
I mean, there's an independent study thing if you want to sort of do your own thing. Yeah.
Mm-hmm. But you'd kind of be teaching yourself.
You'd be teaching yourself, yeah.
That's hard.
So let's take a look at the lab, and there's a couple things we're going to do. You want to continue with Eclipse today? You want to try Eclipse again today?
No.
Okay.
I thought
Good.
we were gonna do Eclipse after the quiz or something like that when we got back.
Totally fine. Yeah, it's fine with me. I actually think BlueJay's easier to work with. So.
No, it's not.
Yeah, if you want to use Eclipse, you can use whatever one you want, but I'm going to use BlueJay for the demo. Okay. And the lab is up here. You can pull that up on your screen if you want. It's and you're going to work with a partner again, so that's you only have to have one computer screen with the lab up, and the other screen can be working on the project, right? So that's why we don't need paper for this exactly. And I'm going to zoom in a little bit. Let's see. So on Monday, we downloaded the whole Lab 2 folder, and inside Lab 2, there's a Lab 2B folder. And if you open up package BlueJay, you're gonna see the Lab 2B folder. What's nice about BlueJay is it shows you the relationship between the classes much better than Eclipse does. you get this nice graphical depiction here. And what you can see is that the stack interface is being used by Lab 2B and also the array stack and the link stack. But these arrows are indicating that the array stack is implementing the stack interface. And the links, and so is the link stack. Yep.
What happened between you and Eclipse?
Well, what happened, James, is I have my concern is teaching you data structures and Java programming, and it's so time consuming. I never have enough time to really master Eclipse. And BlueJ is so convenient, and I also have kind of a it's an ethos that I have of just keeping things as simple as possible, and Eclipse kind of violates that ethos for me. Yeah.
Definitely violent.
And I've used it. It's nice, and the nice feature, the thing that people really like about Eclipse is that when you start typing like an object name, it'll spit out all the methods you could choose for that object. Okay. And it'll do a lot of auto-completion for you, and that's great. It'll speed up your programming, but you can find that information just by looking at the lab or the document, the other documentation that I have. So it's not essentially required. But later on, you'll find it's a lot better. So you might want to play around with Eclipse, and maybe if we have more time here and there. We're never going to have more time. We could bring it into class, but it's never going to happen. It's going to be. It's going to be like this the whole time.
You can pull up Java docs inside BlueJ too if you go control space
cool.
after something. So.
Yeah, so BlueJ has a Java docs feature. That's really nice. Cool. How would that work when I open up a file?
So open up something.
Like if I open up Lab 2B?
Yeah, and then after, say, for example, system.out after the period
on
.out, you can hit control space and it'll show everything.
Like after this period?
Yeah.
Control space.
There you go.
Oh, look at that. Hey. It's now a contender. See, James? Yeah, we're going to all move back to BlueJ now. So David learned that if you put the cursor after some object, any kind of object reference variable, right, and you hit control space, it brings up all of the different methods that you can have for it. So what about the stack interface? Control space. That didn't work.
I think you need to put a period after it, though.
Okay. So like here.
Yeah.
Control space. Yeah, and there's all the methods for. No, but there's something missing. Because there should be push and pop and stuff.
I think you have to scroll down. Yeah.
It's not showing it perfectly, but can I expand it somehow?
I think if you scroll down on the BlueJ lab window.
Oh, right.
Should be like scroll bars.
There we go, see? And so, where is hash code coming from? That's not part of the stack interface. Object. Class object. Remember, it inherits all this stuff from class object. Notify all. Those are from object. Wait. Those are from object. And there's even equals method, which is not really defined, I don't think, for the stack. So anyway, did I start? I think I started recording, right? Yeah, I'm recording.
Does the hash code have to deal with the serializing the objects?
Yeah.
Okay, that's what I thought.
So make a few stacks using interface, array, and link stack. So here's an idea. So here's how this works. So stack interface of string says I'm going to make st refer to a something that implements the stack interface. That's really what I'm saying. st can refer to anything that implements the stack interface. And it turns out, according to our BlueJ display here, that we have oops, wrong lab. We have we have an array stack and a link stack. And they both satisfy the stack interface contract. Okay. So when I compile this right now, it actually is making st refer to a new linked stack of string, and it prints out testing whether it's empty, and then it prints out the stack, and then it pushes a bunch of items onto it, and then it prints out the stack again. So we can run this and see what it does. And there it is running with the linked stack. And forget about the postfix expression, we'll do that. Well, actually, this is going to be the part of the lab that you do after we play around with this thing. Enter a postfix expression. It's going to be something like 1, 2, plus 3, minus. That would be a postfix expression for calculating basically 0, right? 1, 2 plus is 3, and then 3, 3 minus is 0. But this is actually just using the tokenizer to show you the different tokens that it's reading one after the other. That's in the bottom of the program. But we're not going to get to that just yet. We're going to get to... are you guys with us, or are you stuck on something? Or?
No, we're actually
Okay. Well, then don't talk, because you're kind of interfering with my lecture. Thank you. So the thing is, and you're missing out on some of this too, you guys. The whole thing about the interface is that I could make ST, instead of referring to a link stack, I could make it refer to an array stack. And do you think it's going to change the way it runs? No. Because it's a different stack, but it actually works exactly the same. So here's the output from the links. Which one do I use? The first one was the link stack, I think, and the second one is the array stack. And the output is the same. The stack has ball, cap, mitt, cleats. And by the way, when it shows you the output, the bottom of the stack is where? It's on the left. Yeah, so the bottom of the stack is on the left, the top of the stack is on the right. That's just the way we're going to show the stack. Okay. Alrighty, so that's the thing. It works the same. The point is, it works the same whether you use a function. It works the same whether you use a link stack or an array stack. So play around with these guys. Examine and remove items. So number 2A, you're going to print out the top item on the stack, but don't remove it. And then B, you're going to write a loop that says, as long as the stack is not empty, print and pop the next item off the stack. Okay. And then I'll let you do that just to kind of as warm up. And then number 3, before I let you guys just tear into this thing, here's the code that processes the expression. And I've given you all this code already to kind of save time, and just so you can focus on the stack part of the algorithm. But it makes a math expression that reads in the entire line of your expression that you type, and then it makes a string tokenizer based on the math expression that you typed. And it's a special use of the string tokenizer where this is a list of the delimiters. These are the list of the only possible characters in your expression that it's going to actually read. If you type in the letter A or X, it's going to just skip over that. And that's true means instead of actually returning the stuff between the delimiters, it's going to actually just return the delimiters. So it's just going to give you either one of these symbols for everything that you type. Okay? And then you have variables to keep track of the operands. James?
Can you use regex expressions in tokenizers?
I don't know. Regular expressions? Probably. Because you can use them in strings. So maybe I don't know. But this will actually do all you need. You don't have to worry about that part. And then, so these are the operands. And so the trick about this, though, and I'll just explain this real fast, is the trick about this is that the tokens are being read as well, the whole thing is read as a string, and then the tokens are actually character types. Okay? But if we're going to do math on these things, we've got to convert them to numbers. Okay? So to do that, this is kind of what's happening. well, here's our stack, a stack of double. And remember, double is a wrapper class. It actually can hold double values. So you can just push a double value to it. It's just fine. It'll throw that into an object and stick it on the stack. And this is me using an array stack, which is fine. And then it says, while the tokenizer has more tokens, it sets this token, which is a character, equal to the next token, the first symbol of the next token. Okay, that's just getting the next symbol from the token stream. And what we're going to have to do is we're going to have to convert that token into a double. Well, we have to check to see if it's a digit, right, or not. If it's not a digit, then it's an operand. I mean, it's an operator, plus, minus, star, slash, right? So let's look at the instructions real fast. I just want to make sure you got a heads up on what's going to go on here. So don't enter spaces in your postfix, just 3, 4, plus 5 star. And process the token. So what it says is, to convert each digit token to a number, we can use methods in the character class. First, you might Google the character class. But there's a method that you want. The character class has a method called isDigit, which returns true if the character is a 0 through 9 symbol. Okay, and that's the. Oh, you can just click on that link and it takes you to the character class. It also. The other thing you need to know is get numeric value. So if you know that the character is a digit, you can get the numeric value of it returned to you as well. It returns an integer of that particular character. Actually, is this actually going to work? Huh. Well, that might be a little bit of an issue there. Try that out and see if it works. I think it'll work. If not, I have another way of doing it. Is that not right? It does not have a numeric value. That actually may not be doing what I'm thinking it's going to do it. So maybe we should work on that part together. That's the tricky. That's sometimes that can be kind of tricky.
So that takes the get numeric value takes.
You know, now looking at it, I'm reading it. It may actually return the ASCII code of it. Actually, let's just try it. Let's actually not just do the token. Let's actually print out character systemout.println. Here's one way to sort of test this thing out. Numeric. Yes.
Can you just do integers or double dot parse double and then the string?
Let's try that. I think that might work better, but you have to turn the character into a string.
Well, it's a token already.
But it's a token, but the token is the next token is a string, but you got to actually check. See, but you got to know if that token is a digit, and you still have to check it. You have to take it to a character. But it's easy to turn a character into a string, isn't it? You just add an empty string to the character, and now the character is a string. That's actually one nice thing about Java. So let's actually take a moment here and figure out, let's see, let's take the numeric, see if we can get the numeric version of this. Well, let's just check to see, is it a digit? Okay, how are we going to tell if the token is a digit? And we're going to say it's the character class has the isDigit method, and we're just going to pass it this token, which is a char. Okay. Oh, thank you. And this is kind of what I do all the time. I just do these little, let's just do a little test thing. We can check to see if it's a token, and then we can say, you know, if, and then put that whole expression in an if statement. then let's print out numeric format. And then I like that parse double command that James mentioned. I think that's a pretty reasonable way to go. You could turn that digit into a double by saying double dot parse double of double quotes plus this token. You see what I'm saying? That may be kind of confusing, but what that's doing is it's turning this token into a string. But you know, there's actually another way to do this as well, and I'll actually do two different ways. I'm going to do an open curly brace. There's actually a sort of a. This is the way I usually have done this in the past. And I'm just going to take this whole line here and paste it, and it has to do with the understanding of the ASCII codes that's representing these values. And what you can do is you can actually just take this token. So if I know this token is a digit, I can take and just print out this token minus the character code for 0. Okay, and you've seen the ASCII table, right? You know what that looks like, right? The ASCII table. So the ASCII table has the numeric code for each of the symbols that you might type. Now the character in red is what, so this is the symbol for 0 has a the decimal code for symbol 0 is number 48. Now the decimal code for symbol 4, character 4, is number 52. But if I take, so if this token has a character 4 inside it, because the character class, the char primitive is a weird data type. It's both a number and a symbol. The symbol is what you see printed. The number is how it's represented internally. So you can actually subtract two char values, and it'll subtract the numeric codes of the two values. And if we convert that to, so if we take the numeric code for, like if the symbol is 4, 52 minus the numeric code for 0, which is 48, is what? What's 52 minus 48? 4. It's actually the number that the symbol 4 represents. Okay, it's a little strange. I accept that. But what we would do then is we would actually take this, and this is going to be, what format is this data going to be in? This token minus 0, what type of data is that? What type of data is this token? Oh, it's a character though. Actually, I'm thinking that was a char.
The first system out print line, the first one converted it to a string.
Let me just try this once real fast. I have to know if this is going to work or not. Double this token minus, let me just see if it compiles. And compile. Yeah, okay, that works. So, and let's just run it, and then I'll explain any questions you might have about it. So it makes sense, hopefully. And again, this is just a test program so that we can, I don't like that. I'm going to put a, okay. Let's put a \F right where it says empty stack. There, okay. \F is going to clear my screen. And there we go, okay. A postfix expression of process, I'm going to say 4, 5 plus. So is digit true? What it's saying is both of these guys are turning it into a numeric format. Whichever way you like, you can use that to turn it into a number. 5 is a digit, plus is digit is false, so it doesn't try to turn that into a numeric format. Yeah, so now this is just it's kind of testing the interface. So this are the nuts and bolts of how you're going to manipulate the data. That's the tricky part, is getting it from a string to a number. And this either way, this gets it to a number, and this gets it to a number, whichever way you like.
How does it, the second one that you did, this token minus 0, converts into a digit?
Because if you think about it, if you're subtracting a character, this is actually doing a character subtraction. Now the character codes for this token, if you type in the number 4 as a character code, is that number 4 is represented by the numeric code of 52. You see that? And what's the numeric code of 0? 48. And if I take 52 minus 48, I get the number 4, which is the exact same symbol that number 4 was as a character. It's really weird. Okay. It's just working with the language. This is sort of advanced manipulation of data stuff. But you just have to accept some of these things so you can actually do the actual assignment. So the algorithm then is that here we go. Here's the algorithm. And then stored in token val. So there's this other variable token val. If you read the lab, it kind of explains it. And it's kind of a paint by numbers lab. So token val is once you actually have this thing, you could assign token val equal to this, and now that's going to store the numeric version of that, right? If you say token val equals this this expression here, you're going to turn that character thing into a number. Madeline, you had a question?
Oh, I already got the answer.
Okay, good. Okay. So, everybody ready to go? Yeah. All right, give it a shot. What you're going to do is you're going to basically just, you might just comment out these lines, because these are just going to be models for how the kind of stuff you're going to use, but you don't really want to run this every time. So you can comment that out. It's nice to print out the token, and then you might also, while you're processing the expression, you might print out the stack every time through the loop too, so you can see the stack growing and shrinking as it's processing the expression, which is kind of neat.
Did you still have your output window for that one? I just want to double check and make sure that.
I think so. No, but I can show it to you again.
Yeah, I don't know. For some reason, I'm getting where it says numeric format. It's like printing twice. So I'm not sure.
Yeah, it is for me too.
So is
and the reason is these are two different ways you can turn this token into a number. You can say double dot parse double, turning the thing into a string. The double dot parse double takes a string, and you could also say double of this token minus 0.
So okay, so the first one takes a. Let me just so I can make sure I understand. The first system out print line takes a char and turns it into a string.
Yeah, it's a complicated process. This thing is taking and adding whenever you add a string to anything else, it turns it into a string.
Mm-hmm.
So that expression is turning, even if it's an empty string, you're turning that thing into a string.
By adding a string.
By adding a string to it.
Because
Yeah.
I saw it, but I didn't.
I know, it looks very strange.
Okay.
Yeah.
And then this.
Really do new string and make the chart.
So you can say new string of this token. Would that take it? Yeah, that would make sense. That's another way to do it. That looks better.
And
New
then the second
string
one
of this token.
I think you have to keep the other thing. This.
Alright, so
Yeah, there's no string constructor that takes a character. So you still got to say this anyway.
Yeah. I thought
That's just another wrapper around things, yeah. So you have to accept some really weird things. After you see them a few times, you're like, oh, okay, that's how you do it.
Why do you?
it's Java.
And the other one was, I want to try that other thing, which was, according to my lab, I guess I saw that and it looked reasonable, but now I'm thinking that was going to print out the,
What?
The one that he just did.
Print out top.
The wrapper with the string wrapper.
You know what I'm saying? Well, string stack, that's the name of your stack. Your string is ST. You use S string center.
Wrapping the string. Okay. Yeah, it's good to see all of it.
No. No.
so then I did a third way, but I think this is the way that I have my lab doing it. I think that's not going to work either because I'm thinking it's going to give the ASCII code or the Unicode value.
No, because of plus, it's not automatic.
Oh, I guess that works too. Oh, so my lab instructions were okay too. I kind of freaked out when I read it. Let me try some other ones.
Oh, you took the numeric value of the token?
Yeah. Yeah, that seems, it's actually, it's an int, but that's fine. You know, you could turn that to a double.
You can even,
Get
Character dot get numeric value of this token. That actually works too.
or just plus 0.0. It's the same.
Right. Plus 0.0 turns into a double. Okay.
Oh yeah, in the assessment.
Uh-huh.
I accidentally submitted my score, but I only did like 2 or 3 problems.
Oh.
I just wanted to know if it would save it for me to do it later time.
No, you don't have to do submit.
Oh, okay.
It automatically, every time you get a correct one, it records that to the server.
Oh, okay.
So you only do submit once. I can clear that out if you want to do it again.
Oh, okay. Yeah, because I only submitted like 3 problems.
Okay. Who else did, yeah, okay.
The first one.
All right, I'll go back to my office and clear you guys out so you can do it again.
Also,
Okay.
Oh, we submitted.
Yeah.
One
But
Oh.
I was thinking, this lab, you know, there's an extra credit. Did you see the extra credit one?
I mean, you don't, I think you put done, and then you get all the scores.
There's an extra credit to write a static method to find the intersection of two bags.
oh yeah, I did that already.
You did that one already? Okay.
Yeah.
And then I was thinking that if you want to do that that method that you use like 2 stacks to sort a list of numbers, I can make that an extra credit problem too. But I have to find. I don't know if I can find it.
Oh, because you submitted it. Yeah.
Maybe you can, maybe you don't.
To sort a list of numbers?
Yeah.
Use 2 stacks?
Yeah, use 2 stacks. In fact, does anyone have the textbook?
Yeah.
Did anyone bring their textbook?
You made it optional for everybody to
For
go.
all, yeah.
This all and
That's fine. But somebody might have it. And yeah, I think it's in this. I think it's in this.
have 9
While
points.
this tag is not edited.
Mhm.
Using stacks
Yes,
is almost
yeah.
exactly
Well,
how you
I mean,
use it.
that's,
It's not an array. It's not
We're
you only have one value in there and kind of take it out and put it into another one. So it's like stacks work.
oh yeah. Yeah, it's just review.
There's some really good problems in here. Here we go.
But I really,
Following on the sort entries in a
I
stack.
really have to.
Let's create 2 stacks, S2 and S3. And
I gotta make
it's
some.
kind of fun if you want to try
So
it.
it's 3 stacks.
Yeah, well, the data starts off in stack S1,
So,
and then you start with 2 empty stacks. And you have to read the instructions here to figure out how that starts. It's pretty complicated. Yeah, I'll Xerox for it if you want. Does anybody want the
I'll take one.
the algorithm for sorting numbers on a stack with stacks? I'll print out a few copies.
Oh yeah. It's what? Oh, Android. Oh. So you taught it to yourself, or you taught that to yourself or someone? That's good. I know, I'm trying to figure out what because I don't because 1, 2, 3, 4. If B not equal to A, okay, B is definitely not equal to A.
Resize the paper.
Else this, so you're printing
Yeah, that actually works.
this,
So,
and then this,
when you say
and then it
minus,
kicks out.
there's a minus sign there, you say get about numeric
No, this
Yeah,
one
that's
doesn't
what I
either.
have. I'm not blind.
Sorry?
Right?
When you say get numeric value of token,
Yeah.
that token,
Yeah, that works.
it gives you
Yeah,
the
well, it
minus
already
sign.
has it.
No, there's no minus.
It
Yeah.
gives you the 45.
Oh,
Yeah,
just
it gives you
press
a
done
fair
to see what happens.
And then are you sure it's a minus?
Did it give me it?
Well, actually,
Did it give me the correct? It says something.
You have an if statement that say if it's 35.
It's already, yeah.
Let's take and do it before the if statement so you can see it no matter what.
11, 12, 13. Oh, yeah, 17. Oh, I statement. Oh, I have that one. This is so
Are we supposed to have it to where it actually solves the problem right there, or just displays values?
that is crazy.
So the numeric format, let's see, the token is 4, it comes out 4. When the token is 5, it comes out 5. When the token is plus, it comes out -1. Maybe that's because it's not a number.
Yeah.
That's what it means, huh? -1 means it's not a number.
Well, the question I'm saying is, are we supposed to solve the problem that they put in there?
The stack problem. You're going to solve the. You're going to process those now and get a number value. So that uses the algorithm on the handout,
Right. So
which is this one right here. So now you're going to process the expression. So in case you're wondering where to start working, you're going to process the expression on the lab right here. Oops. So line, this add an if statement to test if this token is a digit, and if so,
okay.
Convert it to an integer, then cast it as a double and store it in token value. Finally, push token val onto the stack. So if it's a number, we're gonna push that number onto the stack. Okay.
But what about the operand?
And then if it's not an operand, then you process the operand. If it's not an operand, you process the operators. And here's the algorithm for that. When it's not a digit, it's going to either be plus, minus, star, or slash. So pop an item from the stack, cast it as a double, and store it in op2. Do it again and store it. I'm sorry, did I say op2 twice? Oh, darn it. There's always a typo. That should say op1. So there's a typo in my lab if you guys want to look up for a second. So are you guys getting sort of some sense of what you're doing here?
Yeah.
If you read this carefully, it kind of tells you how to do it. So step 2 is what you're doing with the digit tokens. And so if it is a digit, you're going to do all that step to convert it into a number, and you're going to push that number onto the stack. Okay? And then if it's not a digit, so you're going to say else. That means it's not a digit. It's either a plus, minus, star, or slash. And what you're going to do in that case is you're going to pop one item off the stack, cast it as a double, and store in op2. And then you're going to do the same thing, and you're going to store it in op1. That was the typo right there. Where for part B, it should say op1. Yeah. Maybe I'll fix that real fast and upload it again. Change. Then you have to check if the operator is a plus. You have to add op1 and op2 together and push the result back onto the stack. If the operator is a minus, you subtract them, multiply, divide, push them back onto the stack. It's really fun once it works. It's pretty amazing.
Style, I found a typo in the segment.
In where? In the lab or the code?
The code. Oh, it's in what you have to type. It's the exercise 6. You have it there?
For lab 2A?
The assignment 2, exercise 6.
The assignment. You mean the lab? Lab 2?
No, the assessment.
Oh, assessment. Okay.
Assessment, sorry.
So we already did until step 2, right?
Yeah.
Converting the token into a digit.
Yeah, and you push that onto the stack.
Well, and if it's not a digit,
Then you got to pop 2 values off the stack, convert them to doubles, and then if it's a plus, you add them together and push the answer back on the stack.
if it's not a digit, if it's a digit, put it on the stack.
Yeah. If it's a digit, turn it into a number, put it on the stack. If it's not a digit, so else, you pop 2 numbers off the stack and store them in op2 and op1.
And perform the operation between those 2 numbers.
Yeah, and then push the result back onto the stack. Yep.
So I think we're on step 2. So we actually start doing work at step 2, correct?
Yeah, pretty much.
Okay. So
Yep.
we actually start off at step 2. So this is where I'm supposed to do research.
This is the third step, or this is the third step?
That's a demonstration of the 3-step. What do you call it? It's a demonstration of.
Okay, it's step 1.
I think it's a demo. It's part of the demo.
The stack problems, is it
Oh, so
supposed to
you're
be
just
able
trying
to
to
calculate
understand, what the purpose
more
is.
than just 5, 6 minus? It's
No,
supposed
no,
to
no.
calculate like 5, 7, 9 plus
Star,
7,
yes, yes, yes.
So we
Like that?
start.
Yeah, does it do that?
Because
Okay.
all this
No.
just-
Okay, keep working on it. Yeah.
So we start here. Yeah, process digital.
It's exercise 6.
Why is it so large? Weird. There we go.
Look, do this.
There's a typo?
Yeah. When you try to figure out the solution.
Uh-huh. Okay, so A, B, and then we're popping off, so then I've got a D, uh-oh,
There's the
and
typo.
a, wait,
Oh, which one is the next one?
wait, so we're, S.pop is actually, so we're removing the C, and then we're pushing D, we're pushing E, and then so it should say D, E, C. So yeah, there's a,
It's a E there.
that's an E there?
Yeah. See, it's correct. It's a typo.
Okay.
It should be D.
Okay, I'll fix that real fast, thank you.
Yeah. No, not now. I did try before.
Okay, I'm gonna go to my office and fix those.
Not now.
Okay, I'm just writing, like, this is what we're actually supposed to do, so I'm just writing little comments so I can understand it. So, we're supposed to, in a while loop, after the line that prints this token, which I believe is what we just did, add an if statement that tests if this token is a digit. So is it digit or not? Oh, we already did that? Oh, and if so, write an if statement that converts this token to an integer. Did we do that part too? Yeah, yeah. Okay, so this is the if.
Oh yeah, but we didn't convert it to integer.
Yeah.
Convert it to double.
Convert to integer, then cast it as a double, and store it in token value. We did all that? Okay, so now this is where we push token value onto the stack. We haven't done that. Okay, so but we did the integer? Oh, we did stream.
I don't know if we have to. I
We
think
didn't do
we have
that.
to still change it. The people comment to check.
Where's that?
Token. We should insert token. Yeah, now we have to push it.
Okay, so we don't need this. Okay, but let me just do this. Cast as double. Okay, let me finish. Can I just finish my comment really fast? This is double. This is double. Store in token. Okay, so this is what this is. I just like to have.
No problem.
Okay, so this is.
Whose book did I grab?
Oh.
Yeah, question.
So we have an if statement.
Does that work?
No.
That's why you gotta use those other things. That's why you gotta use.
Okay, but you want to
Cast
comment
double.
out.
No, it's more complicated. It's
Yeah, because you have cast double right there. We tried to use the parse double, that didn't work.
yeah.
So
This,
Yeah, use
but you
that.
gotta add a string to it.
Oh, gotcha.
That turns it into a string. Parse double means string.
Oh, so the better way is to use the way how you did double this token minus 0.
Yeah, actually,
let's see. We have our.
there's 3 ways you can actually do it.
We have our variable on. We have stuck in the face.
Oh, get numeric value?
Yeah, that works too, actually. So my lab was actually correct. I just thought for a second that it wasn't.
The last one. Okay, I can get my notes right fast.
So each one of those ways will work. Whichever way you like is the. If you don't want to type that much, the middle one is the better one.
Yeah, so we have to have a variable and then.
I think the best way is the first one. I think.
Yeah,
Because
makes
this
sense.
sense, and if it's any trouble, the double class will live with it.
Yeah.
Will throw the
Right. Exception.
exceptions and all that.
So we need a variable.
Yeah, but I was
Because we have
wrong.
variable equals.
I was wrong.
That's okay. I mean, unless you do this all the time, it's hard to remember all this stuff.
Because look, if you have to do that, you have to push a double. And the only double we have is this.
So we
Oh,
need to be.
maybe you can cut this. No. You just cut or copy this and paste it.
Copy the double.
Yeah, from here. No, from here.
Oh,
no,
the second one.
no system. This from here. Here to here.
Oh.
Next one. Yeah. Copy
Okay.
that. Paste it.
Double.
No,
Double.
no. You have to. Comma? Yeah.
Push. Oh, but we don't have to put it in a variable?
Now close
Yeah, so we don't have to put it, my question to you is, so we don't need to put it. Oh, now I have too much stuff open. Oh, here, my notes are here. So we don't have to put this in a variable because in all of these examples, they're putting it.
It's not.
We don't need it. Okay. That's all I wanted to know.
Maybe compile.
Choose one of these things.
Ew. Okay, it must be. No, you just have to do like this.
Yeah, but
Oh, yeah, but actually, it was, yeah, it was just. But you put in 3 digits. I think you should try it because you put in 3. You should put in 2 digits and then an operator. You put in 3. So the if. Weird, yeah. But now it's, how do we know that it pushed
Oh,
it?
because we didn't put the system start.
Oops.
But you can make a thing system. Yeah. With no start.
System print and then okay. Shouldn't we? Okay.
Let's try. I don't know.
Well, okay, wait. Can we add something like this?
Another
Is in our stack. Because aren't we, don't we need to print out what's in the stack?
This time we're going to print everything.
Are you getting it?
Oh, maybe we have to.
Let me just see. So push token val onto the stack. This marks individual. Also add a statement that prints out the current stack contents at the bottom of the while block. Then run the program and it should. Oh, you know what? Is it supposed to be current? Oh. Okay, let me take another look at the code just so I can make sure I understand. Okay, yeah. Okay, so while this. Okay, yeah. At the bottom of a while. But where does it say? Yeah, where do we have our other code? Our other. If you go to the output, where did we put current stack is? Where was that?
Stack interface.
Fine. Oh, so that's part of the. So we didn't even need the other stuff. Okay. Well, we could take it. Oh, part of the 2 strings. Oh, okay.
You call that 2 strings.
Cool. Yeah, so,
Okay. So then the next thing, we can delete that, but then the next thing is process operators. So now we'll add this one to our previous tip saver. So,
Else? Oh.
what shouldn't we do? Shouldn't we get rid of? Yeah.
Else? And open. Else?
So what do we
make a new class inside.
So this token is a boolean. So if it's true, you're gonna do it to this else. So then, okay, so we can start writing. So we can go new stack, pop right like this, just copy. Well, I will just type it, I guess. I can't type today. And then is it
Double.
Well, what I'm gonna do
uppercase D?
We are going to receive a double. Double. Okay, you want?
So is it double dot first? Or oh, are we making a variable?
We are going to receive. Okay. Off, we receive. This data.
Okay. So
We have to
happen items in the stack. Pass as double and store in so should we just
I
go
know how to. I know how to do it in my life. Up to we have it.
Yes, just go
Like this. Up to.
yeah, that's what I was gonna say.
Now catch.
Oh, in the uppercase? It's already cast it in the double and store them out to first item off is the last item. Okay. Do it again and store in opt 2. So do it again. Oh, because you want to pop the next one. So, is it just another else?
Who else wanted me to reset their, did someone else want me to reset their assessment thing? Because they put a submit too early? Like Daniel, I saw you, but you were the only one that did it for number 2 yet. Did somebody else want me to reset their assess thing so that they can redo it?
I have a question. So for one of mine, I solved it and it says solve, but when you go and you look at the results, it says 0 points. So I wouldn't want to reset
the numbering. I threw it together really fast, and the numbering starts. The numbering of the problem starts at 0, but on the file it starts at 1. So there may be a skew off a little bit.
Oh, okay. So.
I got it.
Then construct 4 more if statements.
I think it's on the cycle. It's only 2 or 1.
Do we change?
If it's not a digit, what is it copying?
So I think he meant this to be OP2, and then this is
two
the
values
second.
were previously pushed on.
Well, but
Wait, hold on a second, back up a second. Right now, we're trying to declare if it is.
Yeah, because I
It does
know
have
he
a
changed
numeric
this.
Yeah.
Right?
But before, well,
Before that, it would be,
But it's not a, if you start your expression with star, it's not a
well, logically, this should be.
Yeah, it would start with,
or else it would be
it would
null.
start with at least.
But what, you know what, he fixed
You
it.
have to start with at least two
He
numeric
fixed it and he reloaded it.
Oh, so this is actually making sure that there's actually two numeric
So here you
values
go.
for.
Well, it assumes there are. Now you can mess it up if you put an equal expression.
Here you go. He fixed it. So this, the first one is OP2, and then he changed this OP1 plus OP2. I don't know. We'll ask him. I mean,
Yeah, so if.
I thought he maybe he changed.
So if this token, which is.
Oh yeah. Oh, he didn't fix
The
that.
character, right? If this token is plus, so you gotta add the two options together and push them back.
Construct four more statements so that this token is
So it does, if
plus.
it's a plus statement, it
We will
will
push onto numStat
two more
the sum
numeric
of
values in there.
OP.
Well, there are.
And then it'll add the plus statement after.
Okay, let's just.
So it holds the numeric statement, I mean, the plus sign until.
Yeah, the plus sign is held, you pull out the two options. Then you figure out what the sign is.
Okay, well, in the very least, we can start copying and pasting. Okay, so that's cool. One more if statements. So is it if
So now we need to
else?
push it back onto the stack now that we've come along.
Yeah, so you've got that now, you can just get that inside here.
So we're just doing
If it's a plus, if it's a plus, then you're gonna.
four more if statements so that if this token is plus, so
Okay.
plus minus
Operator.
Yeah, you're
multiplication.
explicitly have to do the operation. If it's as simple as a plus, then you gotta.
So it's reading it. Is it a number? Is it a operator? Yeah. So it's gonna pop it. If it's a token, it's gonna push. If it's a number, it's gonna push it. Else, it's gonna pop. Yeah. So if it's a digit. Oh, inside of the else? Oh, so it's gonna pop the numbers and then do the operators. Okay, if it's a token.
This token equals
448 star plus 9
plus plus plus.
448 star plus
Equal.
9.
Okay.
Oh, you got it. Okay.
So wait, what do you mean, how we did it wrong? Why is it? So how did that do it? And we had shortened code. Did this guy?
Like this, equal, not equals, equals.
I know.
Equals.
You don't have equal. You don't have one. No, if it's one.
Under.
Where is the
Yeah, I guess for whatever reason I thought it was equal. I thought more like, oh, string is equals. The
chart?
chart. Oh, okay. If it's that, then push on. Okay. Push onto the numStat.
Where's the If it's plus, it's this.
Oh, and then you're gonna have another if. Because don't we need to do the actual operation? So if it's a plus, you want to add it. If it's a minus, you want to subtract it.
No, now you have to make a push. It's fine.
But you might have to convert that to a double. No, it is a double, right?
It's like
Yeah, those are
Or
plus.
push the two.
But you gotta do single quotes around the plus, right?
Oh, yeah, yeah.
So one of this one are OP one. I don't know. You understand? Tom?
Oh, I see what you're saying. Yeah, because like you have one, just the last two numbers. Okay.
That's valid, right?
Choose on the top of the stack.
But you know, do you know on our lab sheet, which one was OP1 and which one was OP2? He made the correction right there. So like, for example, like,
OP1 is the first one.
I thought that he,
So you sort in OP2 first, and then OP1.
oh,
Because it's a
okay,
stack
okay,
that's-
so OP2, and then that's one. Okay, thank you. So if it's either of those, you're gonna push the last two numbers. Yes. And then you have to actually do the calculations.
We have all of it.
We push onto the stack the sum of, see, I read this as a separate, so if that, you're gonna add it and then push it back. Then if this,
If you do for X statement, it's the same as this one, because it's, if it's this, you do this, if it's this, you do this.
Oh, we just got that.
well, because if it's minus, you're gonna push OP1 minus OP2.
Oh, I understand what you said.
It's separate, but I see what you're saying. This would be like a switch. If it's either one of these, you're gonna push it first, then you gotta still do the calculation. But okay, so what do you think?
I think it's already here.
Yeah.
It was for
But
everything.
but you know what? But it's not clear because look, it says then it says push on the sum and then look the sum and so on for the other. See, it says you have to read ahead. No, that's okay. Else, yeah, it's still good. It's minus.
So it says total value. I thought you just
You get to practice your typing.
Oh, we did it in
What?
we did it inside the graph.
All symbols are different.
Yeah.
Just for the little, yeah.
OP1 minus
What are you telling me? Oh no, we did that. Oh yeah. That's only. Still the operation from what? Still the operation
Yeah. Yeah, see, that's smart to use the number pad over there. Joe. Oh. But I like the brackets. But you don't need the brackets, right?
What?
I like the white space.
But it's faster like this.
Oh yeah. Okay, we'll leave it like that. Okay, I didn't know. I wouldn't know. Like I've never seen it like that. So I wouldn't know. Yeah. We can keep it like that. I know what it means. Put brackets for one and then leave out.
We're pushing the dice because it's only showing after the second value. Try something.
You don't have to. And insert. And insert.
Oh,
I like. Well, see, I personally like white space personally because it's easier to read. It's easy for me to read. The last thing, pop off the last item from the stack. It will be the final answer and print it out. And then we have to pop the last one. So then the last one is we're popping the last value. The last one. After the whole while loop, that's supposed to be loop. while loop processing expression finish. After the while loop, pop off the last item from the stack. So after the while loop. So oh, it goes after. Actually, it's after the whole while. Yeah, see, delete that. That's yeah, because I just typed that. So after the whole while loop. So where does the while loop end? Okay, here. Here's the if. Okay, that ends the if. That ends the while. This ends the while, isn't it? So that ends the else.
That ends the if.
Oh, the if.
Ends this this and no. This ends this else. This ends this. Yeah, this the well.
Your stack one.
Okay, so after the class. Okay, so we should put it right here. Yeah, but we have to pop.
We have to do this one. It's outside. That's the big one. Outside the while, we have to what? Pop.
Okay, so after the while process, then we have to pop the last. See, I don't know. What happens if you delete it? Delete it.
Oh,
See?
yeah.
Oh, you know what? I know what happened. So this stack that you're using was written by a student last year, and the print statement is not working right. I mean, the toString method isn't really working right. But everything else is okay. You can push and pop and that works okay. Because when we just noticed when it works on, it's the same thing happened with Brian, is that when you actually, if you print the stack after every
now we have
operation,
to pop off 8.
when you push the first item and you print out the stack, it doesn't show up.
Finally, after
It only shows up after you got 2 items. But it's in the
finishes
stack, it's actually working
processing, pop
okay.
off the last item
But
from the stack. So the
that was
last
like I
item
found a
is
student
the,
solution.
because that's the bottom and then that's the top. Oh, wait, the last item is the top item?
No, the stack actually works. Don't worry about it. It's the toString method for the stack that has a little
Yeah, well,
the toString method doesn't show you the stack when there's only one item in the stack. Yeah, it's the first time you have something.
stack.
Eight.
8. No, stack. I think, yeah. And then, oh, but wait.
That's right.
Yeah, oh, yeah.
So this token is
But then don't we, can we print, oh, yeah, well, we can.
this token is not
Thank you.
Well, 4 plus 5 is 9, but then what are we doing with the 8? Go back to the output. Go back to the output. Okay. I don't understand. So 4 and 4, 5 plus is 9. But see, I don't understand why are you getting 3? Because
So
what are you going to do with the 8?
I'm following the directions here. So we're taking the item, popping it off of the stack.
Well, no, that's fine, but I just don't understand the.
Else block. Casting it to double. Storing it to
temporary variable.
Yeah. Temporary variable. When I run this, it gives me an alternative.
Yeah, but I'm not understanding why are you putting 8?
After doing
4, 5
something
plus.
here, it empties
It's
out
fine,
the
but I
whole
don't
stack.
understand it.
Oh, you didn't push it on the stack. So once you convert it to a
Oh,
number,
I mean,
you got to push that onto the stack.
Like 4, 1 plus.
No, I just want to make sure, like you're checking off
Well,
labs.
Yeah.
I want to make sure that you have
Have what?
completed us.
Oh, I gave everybody 7 points, but then there was a little extra work to do the grocery
Gotcha.
checkout using the an array of items.
Okay, and then for this one, is it
So 4, 1
you're just checking
plus
lab 2B?
is 5.
Yeah,
And then if you
but
put
So there's probably
minus.
half 5 and 7. We have off.
Still.
If we do this, we have 50. But when we make the top, it's wrong.
Yeah, but no, I don't understand the 7. I don't understand the 4.
to print the
And
result.
1 plus. So
Okay, that's 5. Now, what are you doing with
we
the
have
7?
we have 5 and 7. So we don't have any more or
Okay.
less or nothing.
Yeah, but I'm not understanding what are you doing with it because it's going to be. Okay, my understanding of Postfix is that it's like a mathematic. So it's looking for like a will aspect. But my understanding is if you put 7, then it's like, what are you going to do with the 7?
How did that?
But what I would do for this example is just say 4, 1 plus 1, and then 1 minus. So I don't understand the plus.
Somehow
I understand the plus, I don't understand the 7.
I did division.
Well, what are you putting in for an expression? 1, 2 plus?
1, 2 plus, yeah. So this token I equals plus.
But so you're saying, okay, but you're saying right here though, So, I mean, I'm just trying to understand.
You know what? Wait a second.
Current stack is
Wait,
5.
1, 2 plus.
Okay, so you're saying that if you're adding the set, okay, 4, 1 is
You know, I just had this
5,
great
and
idea.
you're just
Why don't we,
putting
instead
the
of
7
using
here, so
a
that's
array
gonna be
stack,
like that?
let's use a link stack because maybe the two-string method works better. You can
Okay.
see the stack better.
Maybe I just don't, I'm not accustomed to
Because
this.
the array stack pretty much.
Well,
So
the
then-
two-string method didn't seem like it would
When
work.
you have the
So
class,
that's
just,
this.
you don't have any
let's
operation.
just
You
play-
don't have a block.
Okay.
Oh, you think it's
So
not?
then pop,
But that there,
it's
I
supposed
want
to
to
pop
see the
the
stack.
7, right?
And after every cycle, I want to say stack is.
Yeah,
here's,
so
let's
like
just do-
that's, and it's
let's just
supposed to
display
pop
num
the
stack.
last one.
Yeah.
So the stack is supposed to be.
I'm not sure what's happening there because this one,
Payday.
okay, that's 1, 2.
So here's your current stack is 4. See, that works better. Actually, you know what? You can see the stack if you change it to the link stack instead of the array stack. The
Well, we
two-string method
know
for the
that
link
it's
stack
right
actually
here,
works.
right?
Yeah.
5 and 7.
So 4,
Yeah.
5.
So
I think I
Dean,
changed it at the beginning back to link stack.
Dean, hey Dean.
So right now it's 5 and 7, right?
Hey guys.
But then when we pop the last one, we pop the 7.
Oh, well, we can make this maybe. I'm not
Oh,
sure.
is it under the, is your name Brown?
1, 2, 3, 4, 5.
Okay, so
I think
I think
you got the 4, you got the 5,
I'm
and
not sure.
so the
But
current
that
stack
should
is
have worked though, because
0.8,
after you
but
pop the
because
7
it's
and then you print
defaulting
the stack, it should just be 5, right?
I don't know why.
no, but you're using dot equals.
yeah, dot equals. So do you need a
This
lowercase?
token
4
is a
1
char.
plus
Char. Okay.
So how are you able to even do that? You must be casting it as a string.
Yeah,
so
that
just
works.
use
Woohoo!
equals equals
Okay.
single
Yeah,
quote.
but I wonder why it didn't print.
because you make 2 pops. It's crazy. You make this pop and another pop. And
All the way down the line.
you just
That'll
want
work.
the last one. So you,
Yeah, so is it popping this one? So when it pops this here, this one first, right?
No, it pops this, but it do it twice. So the stack is empty, and you take the last one. Now, we're with question. It's we make here the while. If it's this token is a plug, if it do this, if it's like this, and everything is we think it's good. But when we pop anything like this,
Yep. For the final answer?
Yeah,
like
it didn't
this,
work.
um,
And then you have to put back what we had.
the num stack it's empty.
Like this.
It would be there.
It will
Yeah,
be,
it
has to
should,
be
but-
empty.
Well, when you finish that while loop, there's
But
only
we
going to
are
be one value on
yeah,
the stack.
but we are outside the while.
Yeah, after the while loop, there's only one value on the stack.
Oh.
No, but we are.
And actually, if you change this to a link stack, it'll print the stack better.
Okay. Oh, so there's really only one.
No, that is the last one.
Yeah, I have a lot of stuff. Sorry.
Oh yeah, off one.
So check this 11, and then see when you pull off that one last one.
Oh, see, but he was trying to add. He was trying to add one. You want to show him what you were trying to do? He was trying to add for the output.
No, I
If you
was.
just see now you pop it, and when you do it again, there's nothing on the stack. That's why it said null.
Oh,
So
But can you explain to him what you were trying to do? He was trying to add one, and then
if we do this, if we do this,
he was trying to add another one.
I have to stop it.
Yeah, you can do
it's not, it's not like
This, if we do 4, 1 plus,
plus, and then
an
add.
an 8, for example.
well, that's not a finished expression.
Yeah, see, but I think his intention was to do the operation and then add another one. I mean, really, we should be popping.
You got to do 4, 1 plus 8 plus.
8 plus.
4,
No,
1
but see,
plus
I
is
think-
5. What do you want to do with 8?
But see, I think he was trying to add it to the stack.
You did.
Yeah.
There it is. It's on the stack.
That you
And
pop
then he was trying to pop the 8. Oh, it worked there.
Yeah, I don't know why and the other.
We did it before and it didn't.
Because you changed this.
Oh, to the links. Yeah. Okay, we did it and it showed the 5 and
Framework better.
Yeah,
Okay.
it was like, what are you doing? I mean, what's,
It's because of the bug. Okay, I think we got it.
yeah.
Okay.
Yeah.
So it's correct like that, right?
It's showing the stack correctly now, yeah.
It's perfect.
Yep.
Okay, yay, thank you.
Well, yeah, you just didn't do that. Yeah, good. Okay.
Yay,
Good job.
we did it. Thank you.
I got it.
Okay,
I'm
so
adding
I'm
in
gonna email.
a timer to see how long this actually
Okay,
takes.
this is lab 2B,
Because
so
that's
this
quite a
is save. Okay.
The actual
just make sure
process
you
of
do
it?
going through the
Yeah,
stuff
yeah.
like that.
Because
That's
I
I'm
messed up,
guessing
right?
it's
Okay,
probably
var
less efficient than what's built into Java
I need to
already.
just
But unfortunately,
save my.
all the print statements are going to kind of slow it down a little bit.
Wait.
Well, yeah.
You might want to disable all those print statements and show the final result.
Okay.
And check the time before you print the result.
Yeah.
That's hot, right?
Okay, so this is CSIS10B lab. Oh,
10B.
10B.
10B lab.
10B lab. Okay, so I am. I have too many.
Thank you.
10B lab. 2B. Okay, so this was just 2B and the Java file.
That's Java?
Yeah, the Java file is what I'm seeing.
You take CSV, right?
I attached the Java file because what you can do is you can just go like this. Okay, let me. You can. I'm telling you. Okay, so like the Java file, you could always just right click and then open with. I would always open it.
I know how to do it.
With WordPad, it saves all the formatting. But do you want me to copy and paste? Do you want me to put it in the? Yeah, okay. Or you can just import the whole Java file.
Because Java file, they are not open.
You want? I can copy and paste. Are you sure? But look, it's taking a long time. But it says adding, but it's taking a long time. Okay, just in case you don't get this, because see, look, I don't know why it's taking. See, it still says it's adding. But see, the only thing is you use the formatting for this.
We have
Oh yeah, the format text button. Yeah. Oh yeah, it's in Eclipse too. But you know what? This thing is taking a long time. Yeah. Okay. What happens if I just send it? Should I just send it?
I'll just text you. For sure.
Try stop it and try it again. Stop
Just delete it.
Obligation. 14 milliseconds.
Oh, it's because I know why.
Why?
It's because you have it here open.
Oh really?
Yeah.
Java.
Yeah.
Oh, see, I didn't know that. Okay. I press send. Okay, so you got it. Okay, thanks for your help today.
Oh, thank you.
Alright. Time to go home. Sign out. Oh, I'm in this assessment though.
We're finished today.
The do while, right? A do while loop that prompts the user to enter test score into the test. So while the score, do a test score of -1 or the score equals score equals It's not. How How come it's not taking my equal?
Minus and
And so what's just.
It's not taking
So
either
1 minus
equal
all 2,
or.
what's the rate stack?
Because score it's an integer. Not to make nothing.
So it's just like.
Well, you know, I
Oh,
Equals
uh,
equals.
Score
It took the. Did you see that? It took the.
What's that?
It should take equals equals.
One
Oh,
and
oops.
then 2, but then you say minus.
See, it's
Yeah.
saying
So if you think about the stack drawing, we push,
the equals is right,
push
but
5,
this is wrong.
push
The first
4,
one. See, it
right?
likes
And then you do minus.
this.
Oh,
So
okay.
this goes into
You
on
have
2,
to make this
and then it's 5 minus 4.
Right, so then it would give you a negative sign. This way.
Score of
So you
negative
get
1
5
or
or minus, so you get 1. Okay, 5 minus 4. But you gotta push that, you gotta take that 4.
Oh,
I
and
was
so,
just thinking that if we popped it off like the way it was stacked, then it would be 4 minus 5. And that's
test score until it test score of negative 1 or 101 is this.
okay, cool.
Yep.
Well, it's gotta be
Technically, yes.
greater.
But I'm,
It's gotta be greater than negative 1.
I'm getting easier as the night goes on.
You are asking the user to enter
So
that
when do we have
just
to
upload
add
your
any
upload your. You
No,
have to upload
no,
the separate lab steps like 2A and 2B.
score plus
But
what you
it's
enter.
10
No,
points
it's what
I
you
haven't
enter,
uploaded
it's
even
score
today
now.
yet because of the
You
clone
press
thing.
1, now it's 1. You press 10, now score is 10. You press 9, score is 9. You press 2, score is 2. I mean,
But it has to be greater than negative 1, right? I mean, like, it can't be
So in that we only need we created
Did you make
You-
the
single array.
until negative 1. So if negative 1 or 101 is entered, then it's.
the
In 2A the only thing important is just created one.
students to the club of
No, I'm talking about grocery thing. Grocery
So it
thing.
might be
Yeah, lab 1.
score is
So in
less
that there was a
than.
Did you work with an array of items?
Yeah, so just created a one array that has
Then
price and
that's what I look for. If you upload that on.
and then I was working on the
Equals,
extracted
equals.
like intersection of the
Yeah.
See, it's taking.
Yeah, but it's not your problem. It's
Not that hard.
it's the application.
It's a lot easier than the
Yeah.
Princeton class.
Well, because I'm thinking, see, like, it takes the equal, it takes a second.
no, I'm not
Have a
doing
lot
it.
of problems. Lots of books.
So if I just click done.
Is anyone watching
No,
Core
it
Zero?
says, oh, don't press submit.
No.
I know.
Well, I wanted to skip it.
It's really
I
hard.
wanted to skip
Oh, you
it.
have to press next.
Yeah, I'm not getting
I
it.
think I'll
Yeah,
show
I'll
you one
just
of
do
the
it. I'll
lectures.
just
He has
do it.
lectures on algorithm.
Okay.
Like,
So
Okay,
bye-bye.
all right, bye.
I'll do the show 'em all.
Try working on the weekend and then I'll ask you if I have. I recall seeing.
Yes, well, good job, y'all.
So I'm finding that a addition problem takes more time than a multiplication problem.
Oh, really?
At least one time.
Are you timing? Oh,
What's
you-
the time
did
you
you?
got?
Oh, he put a timer.
Yeah,
How much
method?
time?
So 32 milliseconds for 2 plus, and then 2 times.
Interesting.
You
Yeah,
get
you
12
can do
milliseconds.
All right.
And how are you doing your timer? Where are you starting the timer?
Starting the timer after they've entered.
Okay, so you're starting it there?
Yep. Unless I have something backwards.
Well, you know, the thing about timing is, if like the system is getting some request over the network that it's managing, you know,
Right.
it's doing all kinds of stuff in the
At the
background.
same time.
So it's
So if you run it again, is it consistent?
it kind of floats around the same
Yeah,
area.
you may be just getting the noise in the background processing.
Is it because of the other like threads on the CPU are doing stuff?
Yeah, that's all going to factor into the time. So like here's 4. Wait, here's 2 plus again. See, it only took 16 that time. Took 32 that time. So that's an interesting thing. But that Coursera class, he actually talks about those issues when you time the running of your program, and he shows how it's a really interesting lecture, that one, and it's I think accessible for most people to be able to pick that up. But he shows different ways of characterizing how long it takes a program to run.
So I
I'm
should
actually gonna
leave.
watch those videos during the 4-day weekend. Try and catch up.
Yeah, on the Coursera class.
Yeah.
I would watch the. You know, it's interesting.
I just haven't had time
But
lately.
he's actually introducing trees in the first class, and it's kind of it's not that hard, but it's.
Have you checked out the videos
The
for
assignments are hard.
for this book?
No, I haven't seen
there's
any of those.
videos on there. Yeah, because like in the chapters and stuff, you'll actually get like those little signs there that says there's videos.
Check those out. Yeah, you're gonna play.
So, like some of them will be like example tutorials and stuff that you can do online. So you gotta go to the beginning of the book,
Punch your code.
and you gotta scratch that
Oh,
off.
yeah.
Your code. So I was gonna look at those tonight too, and then
Yeah.
get a little more feel for what we're doing.
Yeah, it's interesting if it's Corona who does that.
Yeah, that'd be cool.
He's been doing it for many years.
It's not the same author from the last book.
No, it's this guy.
Okay.
He's from Rhode Island. But I went to his school website. It's like everyone's like raving about his teaching.
Okay.
Yeah, he's a teacher. No, the other guy was a teacher too. The other guy was a community college teacher. He's at the University of Rhode Island.
Oh wow.
The data structure is just such a hard.
Yeah.
So many people.
So for lab 1A, or was it 2A? What all did you want to
2A, just show me the, you know, adding the students to the club that was created for a club of persons. And that working okay, you can find the students and then get the club.
Yeah, that's
You
one.
want to demonstrate the equal method to the students.
Yeah.
And you add, I think they're just adding those students to the club. And then print out the club and it shows the student information.
Okay. Okay. All right.
So.
And that's all. Okay.
Yeah.
Cool.
Is there any office hours on Friday?
No, campus is closed on Friday. But you can email me if you have any questions on something.
Well, it's better when I come here because I got everything here and I have access to talking to you.
Oh, you don't have
Otherwise,
good good internet access at home, do
No,
you?
no. When I'm home, I got other things I need to do.
Right.
So I'll just have to come in.
So you can't watch any video or anything? I'm gonna post a video for the
But we have
Monday.
limited
Yeah.
bandwidth.
Can you catch that later? It'll be a review of arrays and stuff. Hopefully you can pick
When
that
will
up.
you have it up?
It probably won't be up until Monday.
So on that video, are you also going to go over the quiz or something? Because you said we're going to have a quiz on Wednesday.
Do I have a quiz? I
Yeah.
forget. Oh yeah, I do have. I think I have a quiz in there.
And we didn't talk about it today, so all of a sudden Wednesday we all come to class and it's like, boom, you got a quiz.
Yeah. Sure. Let's see. It should be an easy quiz, but that's relative to.
Okay, cool. What's it going to cover? Just stacks and interface?
It might be similar to the assessment problems.
Oh, okay.
Probably.
Are we going to do it like on the computer?
No, but it'll be on paper, but it'll just be something. You know, I did it for. I was doing a bunch of quizzes for 10C, and I had a nice quiz bank, and I just, you know, I made it pretty easy because I gave them a lot of extra credit possibilities. But I don't have a quiz bank for 10B, so I don't know. Like our book doesn't have a quiz bank, so I'm not sure how it's going to look exactly, but I'll give you my best guess. It's really just, you know, a chance to kind of challenge yourself and see how much you're getting out of this.
Yeah, on the assessment, I think there was a mistake.
I fixed the file. Oh.
Because we got 26, but the answer turned out to be 25.
Oh really?
Yeah.
Okay. For which number?
8, okay.
Number 8. I'll.
The second one.
I think that's like the second or third.
Yeah, I make these kind of fast, but.
I like them. They're pretty cool.
Yeah, but there are sometimes some errors.
That right there took me 5 minutes.
Oh, for it to download?
I didn't even download it.
Okay, so let's see. A is 2. So which one? B? Or C? C?
C.
C was wrong?
No, wait, it is.
That's 6.
Let me just go there.
Plus C.
I think you had C here, which you said. For C, you listed as 20. Okay, so.
5?
So C is 4. and D is 5, 4, 5 star, and then A, which is 2, and then B, which is 3, and then star plus, right?
Yeah.
So as we're processing that, 4, 5 star becomes 20, right? And then 2, 3 star becomes 6, and then you add those together, that's just 26. And I have 25 on there?
Yes.
Okay, I'll fix that in my office.
Wait, for B? C. Or C, okay, I was like, wait, B, it should be 5, but C.
Oh, you have to separate them by commas. Yeah.
Yeah.
Okay. Okay, I'll change it. Thank you.
All right.
Listing answers for each.
Good job.
You want to go through A, whatever, B, whatever, C,
Yeah.
whatever, and D, whatever.
And separate them by commas. So it makes you
Okay.
do 4 of them all in one line.
Oh, okay. That's easy.
I was
Yeah.
noticing with 2, it doesn't show the line for the answer.
Problem number 2?
Yeah. I got this thing.
Clear image of the bag of
What the hell did I click?
I'm out of here, man. But I'm gonna have fun playing with that.
I got a question on, because I'm getting this error here.
On your program?
Yeah.
You working, Mom?
Yeah. Yeah. I've been on a lot of weird.
Losing money, that's what you can do.
They're cut back on hours. Why? Because they're jackals.
I can't wait till I'm finally out of the retail.
That's why you keep working.
Just a part-time job for now.
Right over there?
Yeah, just.
Okay, thanks.
No problem. Are you gonna try and get a refresher next semester? When my junior, start my junior year, I have an internship starting.
Told you it was the contained. Everyone's like, no, you need to remove. I'm like, that's what I thought. And it happened to be just for mom.
Yeah.
Simple, stupid statement. Have you done the hydro one? No. On the assignment? Yeah. No, I haven't gotten to that yet. I haven't started the assignment.
I've been doing the
hydro?
simple for you is hard for me,
Yeah.
so.
Like after the lab, I'm like, oh, makes some sense. Okay.
Yeah.
So just creating multiple bags. Because a hydra is just multiple bags, right?
One for the heads and then one for chocolate.
Oh, really?
Yeah.
Oh, cool.
Same for the chocolate.
What is that? That is not the number 2 that's up there.
That's number 1.
How's that number 1?
It says 1 on there.
Because it goes 0, 1. I don't know why.
Well then, number 1 doesn't show the answer. Where does it show the answer? I can type in whatever, but I want to know it's correct. I know it exactly what.
You know what the problem is out here? This token is a pair. Someone else had one word.
While it's not empty,
So that's why you're gonna push it.
where you can click on.
Oh, I see what you mean, the answer line.
know. Where's it gonna come from?
Yeah, that's a good one. You should definitely bring that up.
You getting an error?
Yeah.
It was number 2.
Oh, the other line.
It's number 1.
Which one?
Right here.
There's no place where I can see what the answer is. So I can type in anything and
Here.
was there one spot below this where it should be?
Let me see it on mine.
I was looking at this and I was like, yeah, you got.
No, it shows on mine. I think what happened is maybe you're zoomed in too far.
There it is.
What'd you do?
So you got one letter.
What'd you do? How'd you resize it?
Hold on. Control.
Yeah. So, you know, I hate to keep modifying that thing, but I think it needs a scroll bar.
Yeah.
That would help. But, I don't think I have time to do that.
So does that mean you only got one letter right?
Yeah,
that's
space.
Huh?
Just a space.
Oh, I got it. Got a space. And the commas.
Well, but you weren't. You never did that at all.
All right, Mr. Reebles,
All right.
thank you very much for everything.
Yep. Later, guys.
Have a great weekend.
Does it work?
Yeah.
Yeah.
Thanks.
Cool.